By third grade, the teacher might assume more general understanding of the problem situation, but might still want to focus on a particular word or a particular idea. In this next classroom scene, the headline story presents information, but no question. Notice how Ms. Timothy focuses first on a particular word to make sure the kids understand it, and then moves directly onto the question, what can you say?
Erasers come in packages of 5 for 10 cents, but they can also be bought individually for 3 cents. Think about that. Erasers come in packages of 5 for 10 cents. 5 for 10 cents. But they can also be bought individually for 3 cents. Do you know what that's saying to you? What does individually mean?
Say if we had like 2 erasers, it would come like, an eraser will come in one, and then another eraser will come in like another one.
So individually means 1 eraser, okay? And the first thing that you need to do when you're trying to figure out a problem is, what is the problem really saying to me? That's the first thing. So now you know I can either buy the erasers in a package of 5 and pay 10 cents, or I can buy 1 eraser for 3 cents. Excuse me. So the word individually means 1. Okay, great. Now we understand the problem. You tell me, what can we say?
We can have 4 erasers for 12 cents.
4 erasers for 12 cents. Look at what the information tells us. They come in a package of 5 for 10 cents. Is 5 for 10 a better deal than 4 for 12? Or is 4 erasers for 12 cents a better deal than 5 erasers for 10 cents? Which is a better deal? I want you to answer the question of which is a better deal. Ahmed, which is a better deal?
5 for 10.
5 for 10 is a better deal than 4 for 12, right? And if we know that we can get 5 for 10, maybe we don't want to do this. Maybe we don't. What do you want to say, Bobby?
Like, you could say that you have 9 cents, but you want to buy 5 of them.
What a great problem. This child made up a multi-step word problem right there, the kind that's typically hard for these kids. The implied question is, and how much more money do you need? This kind of inventing of problems is exactly what the headline story is designed to help kids do, so that they understand this kind of problem when it's posed to them. When children are working hard to understand and become competent at the technical aspects of a problem, it's quite an additional challenge to remember to make sense of the context in which this mathematics is occurring. And that, frankly, is something that's hard for all of us to do, and that we need to know. The headline story gives you an opportunity to work with your class on this challenge as well. Here's an example of what happens in a 5th grade class that I visited recently.
I think that 8 is not a square.
Yeah.
Because you could do 4 times 2. You could do 2 times 2. It'll give you 4. And if you keep on going down.
What's the definition of a square number? Please.
Okay, a square number is a number that gets multiplied by itself.
Yeah. So, for example, 2 times 2 times 2?
4.
Is that a square number?
Yeah.
2 times 2 is 4 times 2 is 8.
Yeah.
Why is it not a square number? Yes, please.
No, forget
It's not a square number. No? Would you like to say?
Because when you have a square number, like, for example, 64,
Yeah.
8 times 8 is 64, so the factors that you use have to be multiplied by the same number.
And just 2 times.
Yeah.
So here I used it 3 times, not fair. 2 times 2 times 2 is 8, but 8 isn't a square number, as you already said, because I used it too many times. So let's get rid of 8. Whoops. Okay, so let's see. Are all of these possible? Yes. Okay, now let's see if you can make it make sense. Could Clark be 16 and his sister be 64? No. It would be a strange family. I mean, you could imagine such a thing, but it would be really strange. Let's see if we can make it work. Yes?
You can do like 16 and his sister 25 or something.
16 and 25.
Yeah.
What makes that possible?
What, 16?
Yeah, that pair. Why did you pick that pair as possible? Yeah.
I don't know. It's like a low number or something. It's like a odd number, kind of. Not really, but. What?
I think it's a good answer, but somebody has to say why. You want to say why?
Because 4 times 4 is 16 and 5 times 5 is 25.
So they're both square numbers, right? But why 16 and 64 doesn't feel so good? Why not? I mean, 64 is also a square number. That's 8 times 8, right? But if he is 16 and his sister is 64, what bothers you? Yeah.
Because if it was like the sister was 49 after Clark was 64, that would mean their mother's like 100 and something. And then if you do 16 and 25, maybe she's just like 80 or 70 or something.
Well, how far apart are they as brother and sister in age? In age, how far apart are they if it's 16 and 25? Yeah. Yes. I'm sorry?
9 years apart.
9 years apart. So that's really possible. Could you get them closer together? Could you find some ages that would get them even closer together?